Hi everyone, this is Mr. Sikandar. In today's video, we will learn about Python's tuple data structure. If you've been working with lists, tuples will feel familiar, but bring in a few unique twists. In this session, we will learn about what exactly is a tuple, how do we create a tuple, how do we access the elements of a tuple, the various methods provided by tuple, the concept of packing and unpacking with regards to tuple, the applications of tuple, and the advantages of tuple over a list. Let's begin. Now, a simple definition of a tuple is it's an ordered collection of elements, right? Meaning the elements will be stored in the same order in which you entered. And the next thing is it's immutable data structure. Meaning the elements of a tuple cannot be modified. So this particular point is same as whatever you had about list. List is also an ordered collection of elements. Tuple is also an ordered collection of elements, whereas a list is a mutable data structure where we can modify the elements of a list, but a tuple is an immutable data structure where we cannot modify the elements of a tuple. So let us see how do I basically create a tuple. In order to create a tuple, we just need to put the elements separated with a comma, and those elements can be put into parentheses. So for creating a list, we use square bracket. For tuple, we can just use this parenthesis, and then you can have all these elements separated with a comma sign. You can capture this into a reference variable. Let me say it is t, and then I'd like to print t. Okay. Along with this, I'd like to also try to print what is the type of T. So on observation, you will observe that the elements are printed with parentheses, and you can also see that the type of T is a tuple, or also called as a tuple. In fact, while creating a tuple, this parenthesis what we had is optional. We can also create a tuple without having this parenthesis, right? Or you can consider the same elements, or you can consider different elements. And then let me try to print the same. You can observe it is still a tuple with all these elements. But it is recommended that when you're creating a tuple, you basically put this into a parenthesis. This is about creating a tuple with multiple elements. Now let us say, how do we create a tuple with zero elements, or you can say an empty tuple? So if I want to create an empty tuple, let us say T1, you can just use this, or we can just use this one. Both will create an empty tuple. So I'll try to print T1 and the type of T1. The same way, I'll try to print T2 and the type of T2. So both are tuples. Now let us see how do I basically create a tuple of one element. So if I just try to create like T1 equal to, let us see if I place this element within the parenthesis. Now, will this create a tuple? On observation, we can observe that it is not creating a tuple. If you want to create a tuple with one element, you need to end with a comma symbol at the end. Okay, only then it's going to create a tuple. In fact, even here, the parentheses are optional. Even without parentheses, we can create tuple, but it should compulsorily end with a comma if it has one element. In case if it has multiple elements, in that case, it can end with a comma, or even without a comma also, it will remain the same. Whereas for one element, it is compulsory that it has to end with a comma symbol. Fine. So I hope the concept is clear with respect to creating a tuple with multiple elements, creating a tuple with one element, as well as creating empty tuple. Tuples can have any data type of elements. It can be numerical, it can be strings, it can consist of mixed data types also. Now, next thing we'll try to learn is how do we access the elements of a tuple? Accessing the elements of a tuple is exactly the same way as we access the elements of a list. We just, let us say I just try to create this tuple, T4 equal to, I can just have some elements. And if you want to access the first element, we can just try to write T4 of 0. Then the same way, if you want to access second element, I can use the index 1. And to access the third element, I can use index 2. I can also use negative indices. Like I can just try to use T4 of -1. This will give me the last element. The same way, -2 will give me the second last element, and -3 will basically give me the third last element. So we can use positive index as well as we can also give negative index. We can also access a part of the list using slicing. Like if there are three elements, I'd like to access the elements from second element till the end. I can just write 1 followed by colon, and then you can leave the end index. It's going to access all the elements starting from second element till the end. Or you want to access the first two elements, I can just try to write skip the starting index, then you can specify the colon, then the end index. So in this case, going to print the elements of index 0 and 1. You can also specify the step value. We can try to say, I'd like to access all the elements, but alternate elements, not all the elements, but alternate elements. In that case, I can basically specify step value as 2. Okay, so it did print 12 and 34. Print the first element and the third element. Okay, we can also print it in reverse order with the help of -1 here. Okay, so we basically learned how do we access the elements of a tuple. We can use indexes, we can use positive indices, we can use negative indices, as well as we can also use slicing. Now the question is, can we modify the elements of a tuple? Now, as we have studied, a tuple is an immutable data structure where we cannot modify the elements of a tuple. If you try to modify the elements of a tuple, let us see what really happens. I'll say T4 of 0. Okay, if you just do this, we are accessing the elements. But if this statement occurs on the left-hand side of the assignment operator, then we are trying to modify this particular element. In this case, you can just observe it throws me an exception. And the exception is type error. Tuple object does not support item assignment. Yes, there's one special case. Assume you have a tuple where the element inside a tuple is a mutable object. Like I have this like 12 and 23 are integers which are immutable again. Then I have a list here. Okay. So there are three elements in this tuple. I cannot modify the first element from 12 to something else or second element to 23 to something else. But third element, okay, is a list. So if I want to access the third element, I can just use this. This will basically give me a list here. Okay. Now, if I want to modify the element of this list, okay, so it is possible. I can write T5 of index 2, which will basically give me a list. In that, I can access the individual element and you can try to modify. And please do observe this 34 will be modified to 100. Okay, we can just observe that this element is modified. But yes, we cannot add a fourth element to a tuple. We cannot remove any of these three elements, right? We cannot change the third element from a list to something else, but you can modify the elements within this in a tuple. Now, the next thing is, what are the various methods which are provided by tuple. With list, we have seen that it provides me the methods for insertion with the help of append, insert, and extend. We were able to um, add elements. Then we were able to remove the element with the help of pop and remove, right? And we were also able to arrange the elements with the help of sort. Since all these particular methods modify the list, okay, these methods are not available with a tuple. Then what are the other methods which are available with a tuple? Tuple will only provide the other methods like index and count. The index method basically tells me at which index the key element is present, and the count method basically tells me how many times a given key element is present. Since these two methods do not modify the data structure, it is provided with list and it is also provided with tuple. So let's quickly verify using the index and the count. So we can just use this T5. And if I basically wanted to find index, I'll say index of 12. Remember, 12 is the first element. Okay. And the same way, if I try to access the index of 23, and that will basically give me as index 1. Now, if you have this 100, 45, 56, but remember, these are not one individual element. If I just try to find 100, if I try to find 100 as a top level element, we do not have 100. You can just see if the element is not present, basically throws me an exception called as value error. But yes, we can verify if this entire thing as one element, is this present or not? And the answer is yes, it is present. Fine. Yeah, the next thing is about count. Okay, so count is basically used to check how many times the key element is present. Now, if I say t5.count, and if I see how many times 12 is present, 12 is present one time. The same way, 23 is also present one time. In case if I try to search for 56, it is not this element 56 because this entire thing is one element. So as 56 as an individual element is not present, in that particular case, it returns me a value 0. So tuple only provides you two methods, the index method and the count method. The only reason why it provides only these things, not the other methods which are provided by the list, is because all the other methods modify the data structure, and here we are not supposed to modify the data structure in tuple, right? The next thing is the concept of packing and unpacking. Now, we have seen that I can create a tuple in this way. So this 12 and 23 will be grouped together and it will automatically create a tuple. This basically is a concept of packing. Grouping of elements into a tuple is basically called as packing. Now, if I have a tuple which has multiple elements, I can use the tuple on the right hand side of the assignment operator. I can just use multiple variables. Okay, it should match with the number of elements what you have in the tuple, and it will automatically unpack, and then you will see that X will have the first element of the tuple and Y will basically have the second element of a tuple, right? Okay, I hope the concept is clear, but yes, it's very important that the number of elements what we have in the tuple and the number of variables what you use here should match. So here I have three elements here. Now here I'm just trying to write this. I have only two variables, and then tuple has three elements. You can just observe two values to unpack. Clear? Okay, yes, we can always use other variable here, z, and then I can try to print the value of z. Fine. So we basically learned the concept of packing and unpacking. Coming to the applications of tuple, where exactly the tuple is used. You might have already studied about the concept of tuple even before getting into the concept of list and tuple data structure if you have worked with functions. Now we know that Python provides me a concept where we can return multiple values from a function. Like for example, I would like to write a function called as calculate, where I'll be passing two values. Okay. And inside that, I'm basically doing the task of addition, and I'm also doing the task of subtraction. These two results are stored into two variables called as sum and difference. Yeah, generally we do not prefer using the variable called as sum because we do have a built-in method called as sum. So we can just write total and then difference can be same. Okay, right. So I'd like to call this particular function. First, let me execute this. Calculate. I'd like to pass this. I'd like to capture this result. And I'd like to print not just the result, I'd like to also try to print the type of result. So you can just observe the sum of these two is 30 and the difference of these two is minus 10. But observe the data type of result. It is basically a tuple. So we can see when you return multiple values from the function, then they will be automatically packed into a tuple and the function returns a tuple. Okay. Right. You can return two values or more than two values, but if you are returning one value, it will not be a tuple. If you're returning more than one value in this way, then automatically things get packed into a tuple and then returns a tuple. The other use case is Python provides you a concept of variable number of arguments. Like I can basically have add function. Now, if I try to write this add function, it can only perform the addition of A and B, right? But now I would like to make this function which can work with 2 or 3 or 4 or 5. So in that case, I can just say star and I can use any name for that as such. Okay. So now I'd like to observe like what is the value of A and what is the value of B and what is the value of ARGS. Okay, right. Then I'd like to first verify this, then we'll try to get into how do we perform some, including the ARGS. I'd like to call this add 5, 10. So in this case, you will see A value will be 5, B value will be 10. ARGS is basically in the empty parenthesis out here. We can just observe this is a tuple. And then the total sum of this, which is returned for the function, is 15. Now, let me say if I do have more than this two arguments, and this is allowed because all these things will be grouped into a tuple and will be passed, and here it will be received as a tuple. So we can just try to run this and observe. So we can just see 5, 10, and you can also see this, right? Now, how do I add up all the elements of ARGS into this? One simple way, we know that it's basically some function, we can use that, or we can use a for loop and access all the elements and perform that particular operation. Okay, so I hope the concept is clear. There are two cases where tuples are automatically used. One is when you try to return multiple values from a function, and then when you work with variable number of arguments. Now, what are the advantages of tuple over a list? So when you look at the list and tuple, you see that a list is providing many more options than whatever a tuple is providing. A tuple is basically a subset of a list, right? So we can store elements, we can access the elements. Okay, that can be done in tuple as well as a list. But in list, we can add elements so that the list can grow. We can even remove elements which are not required so the list can shrink. We can even arrange the elements, but all those operations cannot be done with a tuple, right? So when should we use a tuple? We have to basically use a tuple if there is a need for you to work with a data structure which does not modify the elements. That is, use tuples when you want data to be fixed and unchangeable, or when using them as keys in dictionary. Okay. The next point is Since tuples are immutable, internally they're stored in a more efficient form when compared to a list, and they basically make it faster. So to verify this, I'd like to look at two things. One is, let us say, a list. I have a group of elements here, and I'd like to create a, let us try to take this exactly the same elements. Only thing is, the first one will be a list, second one will be a tuple. So here I'm trying to print the data types of A and B. After that, I'd like to understand how much memory does it utilize to represent a list and a tuple. To get to know the memory allocate for any object, there is the sys module, and inside the sys module, there is a method called as get size of, and you can pass on any object. I'm passing a list and a tuple, both have the same elements. You can see the list occupies 104 bytes and a tuple occupies 88 bytes. So from this, we can understand that a tuple is internally stored in a much more efficient way or more optimized way when compared to a list. So I hope the concepts of tuple are clear. Thank you.